This is a Bally Centaur pinball machine, and it was built round about, probably in the very early 1980s. And there's a couple of distinctive features about this. One of them is that it's got this particularly it's decided to play itself. Okay. Yes. As I was saying, it's got some distinctive features, one of which I rather unexpected. I wasn't expecting that to happen right now. It plays itself. When it's not being played, it will launch balls in it from its multiball firing device, and it will play about 6 balls itself. But all it does is it bounces them down the playfield and then drains them. Yeah. Anyway, moving on. One of the things that's most notable about this machine is got this extra boomy voice, and I can let you hear that now. Keep in mind when I play this that it's got an echo, and that was quite complex at the time because echo circuitry was fairly specialist. At that era, it tended to be done with tape loops with multiple heads. But if you listen to this, I want you to consider this. This is very early speech synthesis. It was a really specialist Texas Instruments chip used in this machine to create that speech, and this is what it sounds like.
Challenge or feature, sequence feature, chamber feature, volume feature, bonus feature.
So one of the things that was a problem with these machines, I mean, I got this about, it must be well over 20 years ago I got this machine. And one of the problems is that the echo circuitry is auxiliary to the main sound board, and it used a specialist chip called an SAD 4096, which was really designed, I think, for guitar effects, things like guitar pedals. And those chips age badly. They don't fail in the sense of being damaged by, well, I suppose you could damage them by reverse polarity, but they don't degrade electrically, they degrade physically. There's something about the circuitry in them that actually makes the chip itself degrade over time, and very few of these machines still operate with the original chip. So I'm going to open this machine up now and show you the inside of it, and then we'll talk more about the echo circuit board. So I'm going to lift the back glass out, and this I've unlocked in advance, and I'm going to be very, very careful here because if I broke this back glass, that would be extremely bad news. It's extremely expensive to replace that because it's from a particular era and they're not made anymore. Inside you've got 5 neon displays. It's worth mentioning they are neon gas discharge displays. They operate at quite a high voltage relative compared to other displays. And when you open it up, you've got an auxiliary driver card in the back. I think that's an auxiliary lamp driver, isn't it? You've got the displays themselves with a bit of card over the top to stop you poking your fingers in because they do operate at nippy voltage. In the back you've got the power supply card. I'm just watching, I don't lean into the high voltage displays here. You've got the power supply card with this plastic panel covering that high voltage section because it's not super mega high voltage, it's about 170 volts DC it puts out to the displays. You've got the 5 volt regulator, smoothing capacitor, and then because that's the power card handling with all the power, oh, you know what, let's get closer up to this. I'm just going to get you closer. This should be better, and better lighting too. So here's the 5 volt regulator, and there's some smoothing for the logic circuitry. We've got the high voltage regulator for the neon displays. Then we've got some decoding chips down here for the power transistors that are used to drive the solenoids. They are probably one of the more problematic bits. The solenoids are always a bit of a thing in pinball machines. We've got the main processor card, which has a 6800 processor and then a couple of 6820 interface chips for things like the memory, the RAM at the bottom there, and some dip switches at the side so that you can actually set in parameters like, say for instance, coins per play, how much it costs per play, how many balls and so on. This board has, as so many of them do, it's got battery damage. This is really common. There used to be a little 3.6 volt nickel cadmium battery down here, and they always leak in these old machines, and when they leak it just tracks along underneath the resist and causes a lot of damage. If you don't catch them soon they can wreck the board. So you have to neutralise that once you've removed that. I could have done with cleaning that better, but it is neutralised, which is the main thing. The board down here is the lamp driver. It's got some heavy thyristors and smaller transistors for either individual lamps or clusters of lamps, and then it's got the decoders to drive them. And it uses thyristors on rectified but unsmooth DC, low voltage, around about 5 or 6 volts. And on each half wave, it triggers them at the beginning of the half sine wave, and they just stay latched themselves for the rest, which is a problem if you're using very light LED loads on them. Then we get the sound card. The sound card is interesting. It's a squawk and talk. It's a standalone board with its own processor, and it has the speech synthesis chip from Texas Instruments and some sound chips, and the amplifier for driving the speaker. And this one's particularly unusual in that they were experimenting at the time with external cards. So instead of this connector being the normal one down here, it's got an extended section on it that you can loop the line level signal out of it. And that line level signal used to go to the SAD4096 board, which was here, and it was quite a complex board. But now it's going to this retrofit board, which uses a couple of the original fixings and has somewhat simpler circuitry. And that's what we're going to be taking a look at. So I'm just going to whip this out now, and we'll explore it in greater detail. So here's a picture of the original Say It Again card that was in this. This circuit board here is called Say It Again Later. It seemed like a good idea at the time to name it that. The chip here in the socket is the expensive fancy one. It's made by Reticon. It's the SAD4096. And these things, even if you could get a replacement these days that was new old stock, it would probably be dead. It's just unfortunate that they degraded just because of the technology they used. I suppose ultimately it is a analog delay line or something like that. So it's quite specialist really. Implemented electronically. I wonder how they did that. But it has a lot of support circuitry. And when I designed the replacement card, I wanted it to fit into the existing position using this hole here and this hole here. Just they seemed a good positioning. And I wanted to keep the circuitry as simple as possible, just to allow it to be built on a single-sided board and just fit in. It did involve a lot of experimentation to actually get it down to this form. And this connector here and this connector here are sort of pin compatible with these ones. They're just slight out of position, but they're on a wiring loom, so it doesn't really matter. The main thing is it's really good if you can get a replacement card that you take the original out and you can use the two fixings. In this case, this fixing here is a plastic push-on stud, and the other one's a pillar, and the other one up here is the an actual screw that goes into the chassis of the support rail. So I started looking around for an echo chip, and the echo chip I found was in Maplin Electronics, who are alas no longer with us, and they had a whole range of these Holtec chips that did all these specialist things, and this was quite complex. This one coupled up with a dynamic RAM chip and used it as what they call a first in first out register, which basically speaking, it treats the memory as a big loop, almost as a tape loop, and it processes the input audio, converts it from analog to digital, stores it into that memory, and just keeps churning it round. And just before it reaches the point it would get rewritten again, it reads it back out and then converts it from the digital to analog again, and that converts it back to the audio. And if you look at the schematic for this, the first one is a bit sort of like, oh, it's quite complex. A lot of these echo chips, a lot of audio circuitry is. And I was looking through a data sheet, and each one was aimed at a specific application, but the simplest one of all was the real bare bones, what they call low-cost echo. And it was designed to take a microphone input and use the preamplifier built into the chip, and then put the signal back out to an LM386 local audio amplifier. And all I really needed was the information to take the existing signals, which in this case was pretty much line level. I think it was 0.75 volt out from the squawk and talk card, and then looping through the circuit board, and then the same sort of signal level back to go back to the amplifier on that card. And I worked it out from the sort of block diagram of how the modules were all being used in this, and shuffled the components a bit. And I didn't use the original values. I kind of like to minimise stock of components in the sense that all the blue capacitors here are 100 nanofarad and the two yellow ones are 1 nanofarad. And it's fine. The electrolytic capacitors are all fairly round values as well. It's easier to keep a small stock of nice round values. The things that are different are the resistors, and wherever possible, I did try and stay. That's 100k. That's 100k. That's 10k or 1k. But the only ones that really had to be tweaked. Originally, this isn't the original circuit board. The original circuit board actually ended up with a few wire links and components hovering off it, just because I considered taking a tap from the original Say It Again board from the power supply and just doing it in breadboard. And then I thought, let's see if I can fit it on a single-sided board in the first place. And I just put it straight to copper, and it did need tweaked. It wasn't perfect. And one of the things I did, if you look at the back of this, you can see the tracks are just really thick. In fact, I can show you the tracks better because this is downloadable from my website, but this is so far back that the only way I could really put out a compatible printed circuit board format back then was to actually scan a printout of the circuit board and then store it as a TIFF file, which gave reasonable accuracy when you replayed it, when you printed it back out. This is just scaled up to fit a larger sheet of paper. But to allow people to check everything was all right, I also put a scale along the edge. I did that with a lot of the circuit board scans at that time, so that people could put a ruler up to it and see that it was needing nudged up or down in scale. But you'll see that it's very direct. There are only 2 links on this circuit board. This little link here, this big link here. And the links are, I should turn this around because it would make more sense, because that's the way I had the circuit board before. The links were required for the power rails on the chip. Now, when I started designing this, the Holtec chip connections to the dynamic RAM, they started off quite logical, and you think, oh, that's quite good, it's obviously designed to mate with it. And then suddenly it was like all the address lines were all just random all over the place. But with address lines, it's not actually so critical, because as long as you present, when this goes to a particular address, the same byte of data will be at that address when it reads it as when it wrote it in the first place. So it doesn't really matter the order it writes it into the chip. So I shuffled the address lines and got it down just to those 2 links. It niggles me a very tiny bit. I made this sort of, what do you call it, open source. Basically, MD can download the files and copy it, so to speak. And I even said, by all means, sell them, because, I'm absolutely fine with that, because it's not exactly what you call a mass market. But one of the designs has got rid of these 2 links by making a double-sided board, and that's not in the spirit of the original design, because that means that every other hole is a plated through hole now. And that just for those 2 links, and that makes it harder to service the board. Not that it should really need serviced. I noticed that the jet black board is not showing up too well, given that I had tamed the whole exposure down to the fact I was showing these data sheets and stuff like that. So the original, when I redesigned it, the new circuitry took much less current. And that meant that the original resistor, which was, is the value visible in this? It's not visible in this. But the original resistor used to get really hot. And the reason for that is that there's a 43 volt rail in the machine, marked 43 volt here. And what actually happens is you've got the 43 volt feed return and the squawking top ground. And it applies 2 levels of filtering. When the supply comes in, it goes through that diode. I'm just checking here. Yeah, 43 volt feed goes through this diode and it gets smoothed. There's a filter capacitor and it gets smoothed by the first electrolytic. Then it gets current limited by this resistor, charges up this capacitor here, and then there's a voltage regulator after that with small reservoir capacitor next to it. And that's fundamentally the power supply. It cut it down really simply. There is also a Zener diode down here to initially cut the voltage down to the point that the 7805 can handle that. But the currents are so low that nothing really gets majorly hot. That was one of the things that the original circuit board got really quite hot. I just wanted to tame things down as much as possible just to bring it into a sort of more sensible level. I don't like hot components, well, you know that. I don't like things running hot. I will say that where this mounts in the circuit board, I'm now thinking the heat goes up from that resistor and the electrolytics are above it. That's a bit naughty. It's just the way it ended up. It was the easiest way to design it, and as I say, nothing gets too hot anyway. So having designed it in what I called jokingly chunky tracks technology, which is the easiest to print out, I did release it, and the main reason I released it was I mentioned that I'd done my original version on one of the arcade game forums, and people said, "Oh right, can we get a copy of the circuit board for that?" And I decided, one day I decided let's clean it up, and right at the point I released it, the whole tech chip went obsolete, and the dynamic RAM was also discontinued from all the sellers, and it was like I had to put a note in saying that before you even start this project, make sure that you can get these 2 chips first, because everything else is standard. If you can get those 2 chips, you can do the project. But as it turns out, as time has gone on, eBay is your friend, because the Chinese sellers on eBay have tons of stock of all these chips. You know, any seemingly obsolete chip you can pretty much get on eBay. The rarer they get, the higher the price goes, but these are not that rare. They were very common in karaoke type systems, which means there was a huge market for them. And the RAM chips are still used in some older equipment as well. So that was fundamentally it. You can either, if you've got a Centaur pinball machine, you can either build one of these by going to my website, and I'll put a link down below. But you can either download this file from that page and print it off onto a transparency, and then make your own copy, or just redo it use a printed circuit board package just to clean it up. Or you can buy a ready-made module, because there are people making these modules and selling them with my blessing. You'll often see that the honest ones put my name on them, just as a reference. And one of those, the sellers is Marco's Specialities, I think, stock these boards. But as I say, you have the opportunity. It's all documented in the website. There's a full component list. You can actually download this drawing, this layout, and print off a transparency, and all the component layout placement is here as well. So that's more or less it. There was one other company that produced a circuit board which was a slightly different shape, and it was very clear. All the components were in exactly the same positionings, exactly the same values. And keep in mind that I spent a lot of time shuffling component values to match my standardization of these values. They'd used identical values. It was clearly based on mine. And they folded the power supply bit underneath so they could use it on a smaller board, which meant it didn't fit the original fixings. But then latterly, they did another version, which is the same style as this, but they've shuffled all these components a bit as well, same values. And on one of the pinball forums, they actually claimed that someone in America had copied theirs. Bollocks, they copied mine. So as Centaur would say, no class, human. But anyway, if you see the black ones, the glossy black circuit boards with Clive printed on them, certainly Marco's Specialities sells them, and various other sellers sell them. They are the sort of original versions, but it is an open design. So if you want to make one, if you have in the unlikely event you've got a Centaur pinball machine, because they're actually fairly rare, then you can make one of these boards yourself, and it just restores the full glory of the echo. It restores more than the full glory. I made it better than the original, in the sense that you can slow the echo down to a much longer delay. And you can also, the feedback, you've got a system whereby if it was just a simple echo, that it restored the data and then it played back out, it would just say something like echo, echo, and it would just repeat it once. But by using a feedback, which is the feedback here, I've not marked it, but by using a feedback from the output back to the input, you can then make it go echo, 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 and it will fade away, and you can vary the number of echoes and also vary the speed. So you can make it go sort of echo, 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 really sharp, punchy sounding, or you can make it that really long drawn out Centaur, Centaur, Centaur. Sounds good. You can go to extremes. You can put too much feedback, because I allowed the max, to the point that it will actually go into a feedback loop and it will sound really dramatic when it does that. It's quite fun to play about with. You can tweak these while it's actually running, and it will skew the pitch up and down as well. Sort of, what do they call that? What do they call that when they're playing about with the settings on games like Speak and Spell? There's a name for it, and I've forgotten what it is. Circuit bending. Yeah, it's kind of circuit bending. I don't actually recommend shorting components out though. not actual circuit bending. But yeah, it's an interesting thing. It works very well, and it has restored the voice to many Centaurs around the world. Good result.